Hi everyone and welcome. My name is Sharon from Parrot Products. Today we are going to be streaming a lesson on how one can be able to solve for unknown variables. This is a grade 9 revision lesson on algebra. So our objective for today is number one, just to be able to identify what is an algebraic equation and what components build that particular equation. Then, how can we be able to relate an algebraic equation, which is a mathematical equation, into real life problems? Then last but not least, on this particular session, we are going to solve a lesson. We are going to solve and find unknown variables by solving an algebraic equation. So, what is an equation? An equation is a statement that is showing two expressions that are equal. So if you look at this board right now, you can be able to see that I have an equation which is 4x minus 7 is equals to 5, of which on this particular equation, it is built up of, let's just quickly choose that, two expressions. So on my left-hand side, I have my expression 4x minus 7, and on my right-hand side, I have my term or expression which is 5. So now when we talk about equation, we are saying this particular expression which is on the left-hand side, which is 4x minus 7, is equal to the value 5. But for this particular equation, we now need to identify what is this variable which is making this expression to be equal to 5. So for us to be able to solve an equation, it's like balancing a scale. So if I'm solving an equation, I have to balance a scale, and by doing so, it means whatever I do on the right-hand side of a scale should be the exact thing that I do on the left-hand side of the scale for it to be balanced. So if I'm solving an equation, I'm going to do mathematical operations on that particular equation. Any mathematical operation that I do on the left-hand side should be the same as the one that I also do on the right-hand side. So for me to be able to do so, I am going to take into consideration mathematical operations and their inverses. So if we come here, let's just recap on what are mathematical operations and what are the inverses of those particular mathematical operations. So if you come here and look, we have our operations on the left-hand side and we have our inverses on the right-hand side. It now means when I look at an operation which is addition or plus, the inverse of that is minus. Same applies, the operation minus, its inverse is plus. Same applies if I come to multiplication, the operation multiplication, its inverse is division. Vice versa, operation division, its inverse is multiplication. Then also, if we look at squared, the inverse of squared is what? Square root. So this is just to recap such that when we now want to solve for our equations, we can be able to use the operations and their inverses. Now, we have mentioned an equation. We have mentioned that when we are solving the equation, whatever I do on the left-hand side should also be the same as the right-hand side, which is balancing the scale. And then we have mentioned that these are the inverses that we are going to use to solve our equations. Now let's apply algebra into the real world. So I'm going to use a simple example, which is a real world problem. Brighton, Chloe, and Divine decide to share 20 sweets. Brighton took 8 sweets and Chloe took 3 times as many as Divine. How many sweets did Divine receive? So particularly here, you can see I have 3 individuals who have 20 sweets. And they are not sharing these sweets equally. They are sharing the sweets according to this particular expression that we have. And the last statement is telling you that how many sweets did Divine receive. meaning divine is going to be our unknown variable. So what I'm going to do is I'm just going to say divine, I give you x width. So if I give divine x width, then it means Chloe's widths are going to be 3 times divine's width. But if you noticed, Brighton already took a constant value, which is 8. So Brighton is always going to be what? 8 width. But when I combine divine width, Chloe's width, and Brighton's width, they are supposed to be equal to what? To 20. This is where I'm now going to build my equation. So let me just have more space on the page such that we can continue there. Right. So now it means divine width plus Chloe's width plus Brighton's width should all be equal to what? To 20. This is now where I can now be able to find out what exactly were divine's widths by solving this particular equation. But as you can see here, let me just quickly change there. As you can see here, I have like terms. So before I start solving my equation, I am going to first of all combine these like terms, because here I have x, which is positive, plus 3x, which gives me what? 4x. So it's going to be 1 plus 3. So let's just quickly do that. Right. So here I have 4x, which is coming from x plus 3x. And then I still have this constant number, which is what? 8. So 4x plus 8 should be equal to the number of widths that we have in total, which is 20. Now that we have this is where we now come back and apply the mathematical inverses and their operations. So now I'm going to come back and say plus is inverse is minus, inverse of minus is plus. So I'm going to come to my mathematical operation and start by plus 8. So I want to remove plus 8. The inverse of plus 8 is what? Minus. So this is where now I'll come and say 4x plus 8. I'm just going to change the color so that we can all see the inverse, minus 8. Let's just quickly come there. Is equals to 20. But remember, we said when you are solving an equation, what you do on the left-hand side, you also do it on the right-hand side. Meaning, if I have applied this particular inverse on the left-hand side, I also want to apply the same inverse on the right-hand side, such that now we have our equation in such a manner. Let's have more space there. So now, it now means 8 minus 8, it gives us 0. So I'm now left with 4x is equals to 20 minus 8, it gives us what? 12. Right. 4x is the same as 4 times x. And again, if we go back and look at our inverses, if I have times, the inverse operation of times is what? Division. So I'm now going to come back again to my equation where I have 4 times x and I want to apply my inverse, which is now division. So let's again come here and just apply our inverse, which is what? Divide by 4. But whatever I do on the left-hand side, I also do it on the right-hand side. Such that now, if we divide, it now means I am going to be left with 4 divided by 4, it gives us 1. 1 times x, it gives us what? X. Which is now equal to 4 into 4, it's 1. 4 into 12, it's what? 3. Such that now our x is equals to 3. Let us do a question together. So what I'm going to do is, I want us to do a question where we already have a an equation, and we are going to time ourselves such that we can be able to do that particular question in 5 minutes. Right, so let's just quickly do that. Let's take our clock and let's put it on countdown. Okay. Right, so I'm just going to put the clock here, and let's just have a new page such that we can be able to work afresh on that. Right, so here we have 6 times 2x plus 3 minus 3x is equals to what? 24. So what I'm now going to do is I'm just going to quickly put that into this particular page. That's 6 bracket 2. Let's just quickly check that. 2x plus 3 minus 3x is equals to 24. Minus 3x is equals to 24. Right. So you can see that here we are going to apply first bracket off. So here you can see 6 is being multiplied to this particular expression 2x plus 3. So what you're now going to do is you're going to multiply 6 by 2x, which gives us what? 12x. And then 6 by 3, it gives us 18. And then that particular expression, you're going to subtract minus 3x is equals to 24. And again, you can identify that we have like terms on this expression. So since we have like terms on this particular expression, we can see minus 3x is a like term of 12x. We are going to say 12x minus 3x, which gives us what? 9x. So we'll start with that, 9x, and then we take our plus 18 is equals to 24. Right. Then again we apply those mathematical operations and their inverses. Here we have plus 18. So for us to remove plus 18, we are going to subtract 18. So let's quickly write that such that now it's 9x plus 18. Inverse operation minus 18. Let's quickly do that. Is equals to 24 minus 18. Right. So now let's just add some space there. Okay, so now 9x plus 18 minus 18 is equals to 9x. The funny thing about this particular statement here is I just wanted to add something that we were taught when I was like grade R, right? So you still remember when we were doing maths, we used to count our fingers. So here I'm going to subtract 24 minus 18 by counting my fingers. 18, 19, 20, 21, 22, 23, 24, which gives me what? 6. Like that. After that, we do the inverse operation. Again, we are now going to what? We are going to divide by 9, by 9. And then we have what? 9 divided by 9, it gives us what? 1, which is 1 times x, and it gives us x. And then here, we can see that we have 6 over 9, which I think when we just reduce it to its lowest term, we can have 3 into 6, which gives us 2, 3 into 9, which gives us what? 3. So x is equals to 2 over 3 as a fraction. And that is how we solve that particular equation. I hope from these two examples that we have done, it has at least given you a basic understanding of how you can be able to solve equations. We are going to have another tutorial video where one can now be able to move from linear equations, which we were solving, to simultaneous equations, and more videos in terms of how we can be able to present lessons on the interactive board. So thank you so much for watching. If you have any problems in terms of solving linear equations, please leave it in a comment and then I can be able to help you. But for this, thank you.